This thing only goes for a minute or so, so I'll play it a couple times. Here goes.
Stone balls, ranging from 1 to 3 meters in diameter, are scattered across a vast area in the Torish Valley. Some are flattened, some are split, and others appear to be glued together. This valley of stone balls is one of the iconic sites of Mangistau, Kazakhstan, attracting thousands of tourists every year. Huge stone balls, ranging from 1 to 3 meters in diameter, are scattered across a vast area in the Torish Valley. Some are flattened, some are split, and others appear to be glued together.
Okay, let me show you my stone balls. Okay, my friends, I showed this video the other day, and there's two of these right next to each other in close proximity, and he was saying maybe they could be boobs. It's just gigantic. The guy's standing up on top here. Now, I think these were tendon enthesis. And at first I thought, I looked at it and I said, yeah, it looks like muscle almost. And now I believe, yes, it is muscle. And these are interwoven muscles that wrap around that tendon ball and is inside of there. And it's very similar to the way muscle wraps around bone. And I have one here from one of the giant fingertips. All right, let me just back this up a little bit so you can see. That is the bone ball. All right, this here is the top of the fingertip. And that's the tendon. Now, it's broken off here. This side here, the bone is still in here. You see this? This right here is the casing of the bone ball. Very easy to see. This in here was the marrow, which is turned into really just clay mud. And it eroded, laying flat like this. So this side was down. All right, the guy's finger was like this way. This is the top of his finger, so his hand was upside down. All right, now we got the bone here, and this side has eroded completely away. That's fleshy, tendony stuff, runs right over the top of the ball. The other side of the ball is still here, and that right there is muscle that wraps around that ball. You should be able to see that. Very similar to what we're seeing here. You see the straps running around there? Same thing as that. And then this right here is where the tendon is that moves your finger back and forth like this. So your finger is sticking out this way. This is the top. It's the top of your finger right there, right over that knuckle. It's right here. That strap and that center core to that strap runs down to this. That's the muscle that wraps around your bone. And it's broken off, of course, but I have the fingertips. I have a bunch of stuff from this. But right there is where the tendon started to go into muscle. Right? It's tendon from here over, and then it goes into muscle somewhere over in this area. Right, very quite obvious if you know how to look at anatomy and you understand anatomy and you have a good anatomy book you can refer to. It's absolutely no question what this is. Plus, this came from a complete hand and fingertips and other stuff. And that was DNA tested, the hand. Okay, just to be sure you understand, I don't like to make statements unsupported. I claim that I have giant creatures here that I do. And here's a 2-inch fingertip, a 2-inch hair follicle. There's where the muscle attaches. This side here is the sebaceous gland. The bottom is the hair root. And that's the top where the hair shaft comes out. All right, these little two spots right at the bottom are the vein and artery, the papilla at the very bottom. And again, that's the where the muscle invests right there. So your hair can stand up on end. Now, what else did I say I had here? Well, let's see. I said I had a giant hand. There it is right there. That goes with that knuckle I showed you before. This is the tendon coming down. Put your left hand back like that. You got the same tendon. Your thumb goes off this way. This is only broken off right about here. This thing's gigantic. It's 4 feet wide here, about 3 feet over here. That little piece right here is where it cleaves, so the two bumper pads come together. The tendon. This silver stuff is grip skin. It's peeling off because it's just like a plastic glove on your hand. You have the same thing on your hand. This is made to do work, grip skin. All right, now, I also, and this has been DNA tested. And here was the hair follicle, I showed you that. And what else do we have? We have this one here, which is a gigantic 3 foot long fingertip. That right there is the fingernail. It's very, very well kept, as a matter of fact. This thing's gigantic. It's 3 feet long from here to here. It got to weigh 500-600 pounds. Now, that round pad right there, you see that? That round pad is what bumps into the next bone. It's like cartilage, so they don't scrub bone to bone. Vein and artery. Like I said, that's the fingernail. I broke this piece off so that I could get down and get some blood, because I couldn't get anything off the top. I could see there was no way. So I smashed that piece off, and it actually came off with the fingerprints. Here it is right here. Remember I said grip skin? There it is right there. It's keratinized. Well, what does that mean? Keratin is a real tough thing. This is keratin. That's keratin right there in the feathers. And then you got collagen, which is not as tough. Collagen is a real gooey sort of stuff, but it's also structurally pretty sound, but you can move it this way and that way. Keratin is real tough. Your fingernails, like that. And there's a lot of keratin in your skin, because grip skin is tough. When I broke this off, it came off just like that, just like a scab. I have it over here. I should go and get it. I'll show you. These are the sweat pores. That's the fingerprint ridge. The fingernail was up here, come way, 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 way like this. Hold on. This is it right here. See it? That's the same part. I broke some more off of here so I could get down inside. This peeled right off, just like it peeled off. You see that? That's not, there's no fracture there. This is just like you ripped it right off, just like this. There's no fracture. None, zero. There is fracture here. That's fracture. This is just like a scab. That's how the skin is just laid on there, and it came right up just like that. You know, of course, I smashed it with a pretty good sized hammer. But it, you know, but then you can get down and get blood out of it, which I did, and I had a DNA test, and it's human. You want to see the DNA test? Of course you do. Here they are right here, 10 years ago. And they were very well done. And this was, there's a certain sequence of RNA, of amino acids, basically, in the mitochondrial DNA, bacterial mitochondrial DNA. But it's associated to humans. And it had that in spades. It was very, very dense. Because I took it right out of the blood. I went right into the arteries. Excellent quality DNA sequence from the 36-inch tip when I smashed off and got down inside. Nothing has ever touched that. Nothing ever touched that. No, there wasn't no contamination whatsoever. And the same thing I did with my other ones. I drill holes in things. You see this? This is a no-till. I was trying to get this DNA tested. I drilled it all out and said nobody will test it. They don't want to get involved because they know they're going to get assaulted. He won't do them anymore either. I don't blame him. I know he got whacked for doing it because they say, oh, you're doing false information. No, he was doing real science. This guy's a scientist, very, very qualified and really good to work with. And he found Homo sapien mitochondrial cytochrome B gene and mitochondrial D-loop region. The mitochondrial means mother side. Well, mitochondrial means there's a little energy factory in there, but it's related to the mother side DNA. And everybody has that in them that's a human being. That's all I want to know. Were these things human? And yes, they were. And they were giants. Absolutely enormous giants, as I have shown you. These were not puppies. My thumb is the same size as the width of one fingerprint. And I didn't have to go anywhere for this. It was right on my property. I did sell that piece of property, so I can't get to this anymore. But I do have this chunk of it here, and it has DNA in this piece I have here. So if anybody wants to test it, that'll be fine with me. Yeah, they keep saying, oh, you must have done this, you must have done that. No, I did everything right. It's not up to me to prove to you that I did it right. It's up to you to prove to me that I did it wrong. This is how bad it is in geology. They can't accept that this is a foot. At the very tips, you see these little dots? Those are the digital terminus, I named them, because they're the end at the vein, and then it jumps over to the artery, and it jumps over to the vein. These are the tips of the ends of your fingers and toes, where the blood stops flowing. You see those little dots? A 10-year-old will look at that and say, wow, look at that big foot, Mommy. And there's the blood right there. It would lay dead flat on its side like this. I can tell that's as flat as a pancake. And it was put back up here. This is right outside of Stonehenge. It's like 450 feet down the road. This is where the guy's feet would have been. Up the other end is where his main body was, where they have Stonehenge. And they can't accept to even take a look at this either. Look at that. It's even got a sole built into it. And there's springs inside of here instead of bones. And we have several different styles of these, and they're found all over the United States. I have people sending to me from Missouri and everything. Tish and Kim and all these kind of people have found so many different things. It's distressing to think that our educators can just dismiss and sort of arrogantly. It's not like, well, let me take a look at it. And I just presented my Triassic footprint to a place here. I'm not going to say who it is until I'm going to give them one last chance, and then I'm going to sort of go on the attack mode, because I mean, they won't pay attention. They won't pay attention. They're making all these claims, and they won't pay attention to what they can see right in front of their face. And here's one of them right here. Perfect example. Flawless example. And that's where the heavy-duty blood comes out, right in the front. That's where the blood flows down, right in this area, and then it comes back up. And basically, this is exactly what I suspected. This would be a ponerosis tendon. Coming out of that top, there's a strap that probably laid flat somewhere, because these are all layers of tissue. A ponerosis tendon locks in strappy flat tendons into flesh. And this is flesh. So there's a ball inside there, and a strap ran over to somewhere, which has eroded away now. The strap is gone. I do see other ones in Arches National Park. They still have the straps attached to them, and the ball is right underneath there. And the flesh has eroded away from the ball. It's just the opposite of this almost. You see this? This is basically opposite of what we just saw. The other ones that had the muscle still wrapped around. This muscle's gone, but it would have been all in here, because the strap runs around to the tendon, and the tendon is gone, the muscle's gone. The ball's still here, the strap is still here, and you can see this is what it looks like in us. There's the ball, and there's the strap. The tendon has eroded, and it left the strap attached to where the ball should be stuck in. This one's ripped out. This is an injury. And these are the tendon straps. And the reason these little tags are here, they just broke these off and made these walls down in Peru and everything. I can show that in pretty good detail. But this ball and that strap is what we saw over there at Arches National Park, right here. That's it right there. And there was another one here. There was another one right here. And it broke right off, which they do. They break off normally. This one didn't for some reason. But you can see the ball is still here. And there's another ball right here. And there's other balls over here. They're everywhere. There's another one here because this is locked in. Did I show you this, the aponeurosis tendon? This is tendon. Tendon. And that's your girdle that holds you together. And your muscles pull against the tendon. The tendon just goes like that. The muscles can do quite a bit of contraction and so forth, but not these. These are tough. There's almost no blood in them. That's why they're white. Right here is, I believe, where we were looking, where they invest into the muscle. And the muscle just wraps around them, is what we saw quite obviously in the shot where he was in the desert here. That's the muscle wrapped around, and the tendon would have gone this way. And these are just different layers of skin. The sizes of these creatures, the human mind just cannot perceive. And believe me, I found that that's the more educated you are, the harder it becomes to be able to understand truth and reality. You're so menticide, really. Menticide means you've been indoctrinated to believe a certain thing, and if you don't believe it, your life is in danger, and it literally is in the academic realm. They will ruin your life if you don't repeat what they say. So that's why we've stagnated. Nobody can understand what they even see anymore. They say, I don't want to see that unless it's peer reviewed. Everybody else got to say the same thing I say, or I'm not going to say it. Well, that's not the way I work. That was an aponeurosis tendon anchor, almost 100% sure in my mind. You know, the more you search, the more you find. I always looked at these and I wondered, why are they so fractured up and scruffy looking like this? These are aponeurosis tendon as well. And the muscle wraps around and is embedded in this in a muscle orientation, like muscle fibers. You can see it in here. And muscle contains a ton of red blood. The reason they fracture like this is something called iron banding, where the black blood and the red blood do not mix. They push each other apart. Now I have a heart here. All right, this is a heart. And that's where the aorta was, the different ventricle valves and so forth right up here. All right, now you see it's all fractured up like this? I didn't fracture that. The reason it's all fractured up like that is because it was laying sideways, flat like this. And the layers of blood separate each other. So you get a layer, then another layer, then another layer, and then they just crack and they fall apart. You see that black? The other side's red. Red, and in between the black and the black is the red. See the red? Same thing here. So the black pushes the red away. They will not mix. They're not made to mix. So anyway, that's what causes this cracking effect. And now I'm literally certain the aponeurosis tendons are all wrapped in muscle. A lot of tendons are not. They're in bone. They're a different story. And then you also have the interstitium balls, which are they're not tendon. They're a little different. They're very floppy little, and they create the Moki marbles. Let me show you those. So now you see these. Those are pretty good sized tendinenthesis. You know, these are good sized creatures. All right, now this is extremely cool. This is skin. You see this white clay looking stuff? That's kaolin clay. It's a powdery clay. This, I believe, was a creature's like facial area, the really soft, they call it slip skin, slip clay or whatever. And the strap that was holding this ball in place came down like this and wherever it went to. Now there's other straps here. The balls are missing. But that ball was literally something that was in your skin. It just makes your skin be able to go this way and that way, and it comes back to where the ball was anchored. We're going to see these in some detail. There's a couple things I want you to take away from this before we move on. This is where the strap came in. Now look at this carefully. Every one of these is literally a layer of skin. One right after the top of the other. Boom, 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 boom. And this, now you see the size of this ball. In us, you need a very good microscope to see that. So think of how many layers of skin we actually have that they, I know they don't know this that well. They haven't paid attention to the extreme details because you can only see them when you get to the size of the things I work with. Okay, so this is another one of these ball type clusters. Well, why is this thing just like that? And then a little stalk. Something's underneath got to be holding it there. There's got to be some big anchor base. And there's another one just like that down underneath. And that's because it's the same as like this bone. And if you can see those little tiny holes. You see those holes? That's where those bumps fit into, these holes. Might have a hard time seeing it, but they're there. And that would hold up to another bone like this, and they'd be able to wiggle and wobble around, but still stay attached. That's how your wrist works, and all kinds of bones in your body. And there's one of these anchors here, which is a ligament, and it comes to one of the anchors over here, which is underneath here, which is the other side of the ligament. So that accounts for this kind of crazy looking thing like that. I mean, there's a number of different styles of these tendon entheses. This is another one. It looks like it has flint or chert or whatever around here, very tough stuff. And then a central core there. Just pictures people send to me that they can't understand, and I don't understand some of them, most of them. See, there's Sam Aswagowicz over there in Bosnia, and this has one with a nice clean scale around it, but see, it's got here, then it's got here, and then we get down to here. Originally there was an enthesis strap right to there. It's gone now, because these are the tough ones. The straps, not so tough, and the springs also not so tough. These, tough. All right, just to give you a quick overall of tendon enthesis. Under your skin, you have a fluid-filled highway with membranes, and in that area, you have all these little anchor balls. See these little black balls? The brown is like a spring, and that springs open these fluid-filled bags. You can pull it, and it'll squish. That's okay. But when you let go, it's supposed to open back up again and be tagged into wherever it's tagged in. The orange stuff here is called collagen. It's a really gummy, gooey, can move very easily, very fluidy, but it's still structural. Then you have the springs, which are the straps. Then you have the anchor, which is the ball. The ball is tough, not so tough, weak. Everything erodes. When they erode, the balls drop down, and all of that stuff turns into mud. And can we see that on the earth? Yes, we can. Right here. This is the United Kingdom. That's skin. I'm just telling you, that's skin. This is the flesh underneath that has eroded. And the balls are here. They call them stromatolites. Well, they don't just grow there. These are from the balls. And what the reason they're all look like they're growing is because the moss and whatever is on here is eating the edible flesh that was surrounding those tendon balls. over in the desert, they've eaten everything. A long time ago, a zillion years ago, well, now, it really wasn't all that long ago. We'll be talking about that at some point. But these are the same balls, only they're quite a bit smaller, obviously, and they are now completely eaten. All the stuff that was on them got eaten and then just washed away as mud, because these are in areas where there's a lot of mud where it runs off. These are sitting on a basement layer of skin right now. That's the basement layer of skin. Above that would have been flesh, just like this. And then there would have been skin above that. That all washed away, and that's what's left over is the balls. And they're in our skin, and they're everywhere. They're everywhere in your body. You see these? And remember I showed you all the different layers of tissue that they don't take into account? This is basically like what's in your skin. It's just above your skin. There's so many layers that nobody ever really paid attention to the depth of intricacy here. It was always sort of a thing to look at, but once you look at against the earth, there just is no way you can deny this. We live on gigantic, decomposing creatures. Okay, I'm just going to go through everything real quick, make sure I didn't miss anything. I don't think I showed you the moon today. I've been showing that quite a bit. That's the dark side of the moon, and these different colors represent different types of tissue, because the moon is biology. That's being ripped away from each layer of tissue. There'll be phosphates between each layer. All right, and I know what this will be, red clays and so forth. Now, that's one picture of it, and these two little dots that are on there are very important to understand too. Why is that one red and that one's yellow? Why has that got a dot in the center of it? All of these things I think I can explain. Now, I showed you my giant hair follicle. This is a tendinenthesis. This is where they rip off. You see that? And here's the little dot in the center, the tag that they're originating. All these little divots here are the same as these on here on a tendinenthesis, so that it can stay and not get ripped out. They're little anchorish little spots that give it something to hold it. I showed you my giant hand. I showed you this thing. I showed you the tendon, all the balls and skin and the fascia and the fluid-filled highway and all the balls and different layers of tissue that are in your skin. They're just staggeringly a large number. There's Sam Oswegowicz. That's basically just almost identical to what happened to our moon. There's this layer here, a layer here, and a layer here. They're, I'm sorry. I didn't do it. It's not my fault. This is Tetchus, another moon. All right, this is, I showed you all this stuff in that. This is inside in the ocean. It's the same stuff there. Those are all the balls, just like the Moki marbles. They're everywhere, spread across the ocean floor, seemingly with no apparent pattern. It was skin. That was skin on some gigantic creature. And here's what they look like in the Moki marbles. That was skin, or the whole thing. I don't know how high it would have been, not too much higher than that. And the skin eroded away, and then the balls just eroded out. And they formed mud over here as it eroded off of the crown. And this is the basement layer of skin. I showed you all these different things here. I don't think I showed you this, but this is the same thing. Only this has the stalk coming up. I don't know why. Here's this piece broke off. This one's a little out of place, but they come here, they come there. I can't explain every single one of them. But I think I've explained enough to make it pretty obvious that these things are biology. And even like that head's real. You see how the moss is growing in here? It's trying to grow in where it can grow in to get some fleshy stuff, see it? It's a different world than we were taught. By the way, maybe Vladimir, maybe he could talk to Trump and they can go out looking for mud fossils together. You know, the funny thing is, I think I got a pretty good following over there in Russia. Over there, instead of YouTube, it's called RuTube, Russian tube. And I guess I got some followers. I don't know. I don't go up there, but anyway, that's what we're into. This is what the whole world is about. It's been just a system of denial. We can't explain it, so don't talk about them. Don't even explain. There's so many of these things in so many places that most people have never even heard of them because they don't want to speak about what they can't explain. You can't explain it, don't talk about it. Because then the kids are going to start asking questions. Well, how can you explain this? Well, blah, 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 blah. And then, oh, that's a concretion. That's what they say. I'm not kidding you. That's what those are concretions. I said, well, how did that concretion happen? What would have caused a concretion like this to happen? Well, it's magma. It always ends up volcanoes or magma. When they can't explain something, it's either erosion, sedimentation, or magma. The evidence is so overwhelming, all we got to do is get a foot in the door. All right, that's another day in Mudfossil land. We need to get this examined. It's just to let it be seen. Right now, I'm so suppressed, it's unbelievable. I can't believe, I know what's happened. They consider me to be misinformation. And now there's a big thing about misinformation. We can't have this nonsense being said to confuse everybody. Well, I don't confuse anybody. I am so obvious about what I'm showing, there's no confusion. The confusion is why is it not allowed to be seen? That's very confusing to me. Especially when these kids are paying thousands and thousands and thousands of dollars and going in debt to these universities to get a piece of paper that says I can say what you told me to say. It doesn't matter if it's right or not. As long as I got the piece of paper, everybody's happy. Well, not me. I want to know what's true and what isn't true. And if you can't discuss what's true and isn't true because a peer review says, no, don't let that guy talk. Do not let him publish. Don't let him get in front of the public. He's going to ruin everything that we built. And they're true. That's a fact. And don't worry, it's coming. There's no escaping this now. And you should be part of this. If you're not speaking up, you're not doing your job. All right, I love you all. Bye.